Welcome to Online Precalculus. Today, we are going to be covering section 4.5, graphs of the sine and cosine function. Our objectives for this section is going to be pretty simple. We're just going to understand the graphs of sine and cosine, and then all the variations of the graph of sine and cosine. That includes stretches, compressions, horizontal shifts, vertical shifts, and reflections. But in sine and cosine, they have special names. And then we're going to finish with some modeling periodic behavior. So, first, the graph of sine of x. We should remember that the function y is equal to the sine of x produces the y coordinate of the x angle somewhere on the unit circle. Okay, so this function y equals sine x can be graphed in a rectangular coordinate system by taking the input and plotting the output, right? Putting in an angle, getting out the y coordinate. Okay, so when we graph y is equal to sine x by listing points on the graph, but eventually, as we go around the circle, right, as our angle increases and we go around the circle, the values of the function are going to repeat. And because the period once around the unit circle is 2 pi, we're going to graph this function on the interval from 0 to 2 pi and then repeat it, right? The y coordinate here on this angle is the same as the y coordinate on an angle that goes all the way around. All right. So one benefit of the graphing the sine function and the cosine function is that we only have to graph one period and then we can repeat it. So let's graph one period. All right. So here are some common angles of the sine function. So if x is equal to 0, the y coordinate at 0 radians is 0. At pi over 6, the sine of pi over 6 is 1/2. And let's actually stick in pi over 4 right here because it's one of our key angles. The sine of pi over 4 is radical 2 over 2. The sine of pi over 3 is radical 3 over 2. And the sine of pi over 2 is 1. Those all come from the unit circle. Okay, and right, if we think about the unit circle, right, what are we doing? We're traveling along here. The y coordinates are going up. Now, as we travel into the second quadrant, the y coordinates go down. This is radical 3 over 2. This would be 3 pi over 4 in the middle here. That's radical 2 over 2. Then 1/2, and then down to 0 at pi. Now, as we travel into the third coordinate, or the third quadrant, the y coordinates become negative. So this is negative 1/2. That would be 5 pi over 4. That would be negative radical 2 over 2. And this is negative radical 3 over 2. And negative 1. Okay. Then as we go into the fourth quadrant, the y coordinates is still negative, but they start to get a little bit bigger. So we have negative radical 3 over 2. At 7 pi over 4, it's negative radical 2 over 2, negative 1/2, and then back to 0. So when we look at this, we can see that the values are going up 1/2, right? If you need to compare these, 1/2 is 0.5. Radical 2 divided by 2 is about 0.7, and radical 3 divided by radical 3 divided by 2 is about 0.86. So you can see that these values are going up. They are increasing until you get to 1, and then they're decreasing, 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 and then they're increasing again. Just like the y coordinate, increasing, decreasing, and then increasing back again. All right, so if we were to now draw this picture, right? Let's call that 1. Let's call that -1. This would be my first coordinate, 0, 0. Then, right, the y-axis or the x-axis here would be labeled in terms of angles. So while these are numbers, output values, these would have to be values of pi. 3 pi over 2, and then 2 pi. So it's going up. At pi over 2, it's 1. So we got some coordinates like this. At pi, we get a 0. At 3 pi over 2 is -1. And at 2 pi, we get a 0 again. So here it's going up, down, and then back up. And we get a curve, which looks a little bit better when the textbook draws it, something like that. And you would see that pi over 4 would be, right in the middle there for radical 2 over 2. This is the graph of one period of the sine function. And remember, try to understand exactly what's going on and visualize exactly what's going on. As we travel around the circle, as we travel around a unit circle, we are outputting the y coordinates for specific angles. And here's a nice visualization of this with the sine function. We'll talk about the cosine in a little bit, right? But you can see as the sine function goes around, as the angle goes around, as theta gets bigger and bigger, the value of y is plotted in an xy coordinate plane, right? Just what we're going. It's kind of a little hypnotizing if you stare at it for a while. But, right, we're plotting the y coordinate of the value at these particular angles. Okay? And we get a graph that looks like this. Okay? All right, so we can obtain a more complete graph of y is equal to sine x by keep going. What we just graphed on the last page was from there to there. That's one cycle, one period. The graph then just keeps going forever. We can extend it to the right, we can extend it to the left. And this is called, the graph of the sine function is called a sine curve. And any part of the graph that corresponds to one period is one cycle of the sine curve. So one cycle can go from here to here, from here to here, from 4 pi to 6 pi, or any period of 2 pi. Okay, so some properties of the sine function is that the domain is -infinity to +infinity. You can plug any angle you want into the sine function. You can plug negative. Remember, the input is an angle. The output is a y coordinate at that angle. And it gets a little confusing when we talk about cosine, but remember, we're plotting this on an xy plane. The x-axis represents my angles, which is why it's in terms of pi, in terms of radians, and my y-axis represents the output, the number. Whoops. Okay, so domain is all real numbers. The graph extends indefinitely to the left and to the right with no gaps or holes. Range is from -1 to +1. Okay, the sine function does not go above -1. Or sorry, it does not go below -1. It doesn't go above -1 unless we make it just with a transformation. But we're talking about the parent function here. Period is 2 pi, and the pattern repeats every interval of length 2 pi. And this function is odd. It is symmetric about the origin, right? If I have a point that's positive, right, this coordinate right here would be pi over 2 comma 1. The input, the x coordinate would be pi over 2. The output would be 1. In order for the function to be odd, this point has to be on the graph. And I see that it is. Okay, so This is an odd function. It means that the sine of negative x is equal to the negative sine of x. And BC, it's symmetric about the origin. Okay, so we were able to graph one period of the parent function. If you remember from chapter 1, we took all our parent functions and we moved them. We added stuff to the outside of the function to move it up or down. We added stuff to the inside of the function to move it left or right. We reflected in the x, we reflect in the y. We did a vertical stretch or a vertical shrink. We did a horizontal stretch and we did a horizontal shrink. Okay? We are going to do all of these on the sine function and the cosine function, but they're just going to have different names. And if we look at my sine and cosine function, that number there is going to vertically stretch or compress the function because look where it is. It is in the front. Okay, this number there is going to horizontally stretch or compress the function because it's right there. This number there is going to shift the function left or right because it's inside the parentheses. This number right there is going to stretch the function or move the function up or down because it's outside. Okay, and again, we don't call this a vertical shift or vertical stretch or compression. We call it something called the amplitude. So we get our amplitude, we have our period change, we have our phase shift, and we have our vertical shift. The only one with the same name, vertical shift. All right, and let's start to talk about how all these transformations work and start graphing variations of the sine function. Okay. So to graph these variations of y is equal to sine x by hand, which we're going to do, we're going to not worry so much about the points in the middle. We're going to sort of focus on 5 key points. Intercepts, kind of important, places where they cross the x-axis. Maximums and minimums. So if we look at one cycle, one period of the sine function, we are going to have 3 intercepts, a max, and a min. And as we go left to right, it's going to go intercept, max, intercept, min, intercept. Okay. So this maximum occurs, if this is the whole cycle, all the way to 2 pi is one cycle, the maximum occurs at a quarter of the period. This one occurs at halfway through the period. This one, the minimum, occurs 3/4 of the way through the period. And then we finish with an intercept again. So graphing key points, when we're graphing the sine function, are obtained by dividing the period 2 pi into 1, 2, 3, 4 equal parts. Like this. We start the cycle, we start the graph. For now, we're going to start it at 0. Eventually, we are going to shift the function, right, left or right, okay, but we'll get there in a minute. We're going to start the function for now at 0. Then every key point comes a quarter of the period later. This would be the beginning and intercept. Let's look at the sine function again. The first point would be an intercept, then a max, then an intercept, then a min, and then an intercept again. Okay. And again, when I think of the general shape like this, you can kind of remember what the general shape of the sine function is. If you get confused, remember the y coordinate as you spin around the circle. 0, max, 0, min, 0. Okay. So the y coordinates of the 5 key points are obtained by evaluating the given function at each of the values of x, or actually sort of remembering what happened on the unit circle at those different coordinates. Okay. So in general, the graph of y is equal to a sine x, so now we're putting this first transformation there. Okay, so basically if the sine function, if the parent function, this function, can only travel between -1 and +1, as soon as I put a number in the front there, it now is going to take that maximum and minimum and multiply them by a. So this new sine function, if I put an a right there, will travel in between the negative absolute value of a and the positive absolute value of a. If a is positive, it's going to just go higher and lower that way. If a is negative, right, now we're going to have a reflection. So the basic sine curve, if a is bigger than 1, if the absolute value is bigger than 1, we are going to stretch the function out. And if the absolute value is less than 1, if it is a fraction, we're going to compress the function. And we call a, this number, whatever it is right there, we call it the amplitude. Okay. The maximum value of y on the graph would be right, that a right there represents the amplitude. Okay, so when I graph variations of y sine x, I'm going to sort of follow the same sort of steps, and we're going to start basic, and then we're going to add some complexity to this. All right, but the first thing I do is I always identify the amplitude and period. Well, amplitude we just talked about. Period we haven't talked about yet. Okay, so the amplitude is usually pretty simple to identify. It's a. It's the number that is right there. Okay, so identify the amplitude and period. Okay, then find the values for x for the 5 key points. The function will always start at its phase shift. So we haven't got to that yet. So for now, we're just going to start at 0. Then the other key points will always be a quarter period later. So when we find the starting point, we just add quarter periods, right? The period divided by 4. We just add the quarter periods to find the next values of x, the other x values of the 5 key points. Then we find the y values of the 5 key points. Okay, and the way we do that is evaluating the function for each value of x. And I'm going to show you a trick to this. Okay, we're just going to use the unit circle and the amplitude to help us change the points around. And we're going to connect them, and then we're going to repeat them as much as we want. So let's give this a try. Okay, right, key points, right? We already talked about this. 4, 5. Start at 0 for now, right? The function will always start at its phase shift, and for now it's going to be 0. The next one will be a maximum, then an intercept, then a minimum, then an intercept. Okay? And this will get a little harder as we start adding stuff in. Okay, so determine the amplitude, and then graph the function y is equal to -1/2 sine x. I don't want to graph them both, right? We already just graphed that, the parent function. Maybe I'll graph the parent function too, but we'll see. All right, so identify the amplitude. The amplitude is 1/2. The period, there's a formula to get period, but for now, we haven't changed the period. A number right there would change the period, but we haven't changed the period, so the period of a standard sine function is always 2 pi. Okay, now, the values of x. The first x, the first point, the function will always start at its phase shift. This function has no phase shift. We haven't even talked about that yet. So we're going to start this at 0. Then, besides knowing the period, I need to know the quarter period. So the quarter period is the period divided by 4. So 2 pi over 4 is pi over 2. Okay? To get the values, all right, and I'm making coordinates here, okay? To get the values of the x values for the 5 key points, we start at 0 and we add a quarter period to get the next value. So 0 plus a quarter period is pi over 2, then pi, then 3 pi over 2, then 2 pi, right? And that is half of my coordinate, okay? Next, find the y values. So let's make this a little bigger. Okay. Shouldn't have made it that big. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we're taking this nice and slow here. And now we want the values of y for my 5 key points. So my function, which was 1/2 sine of x, if x is 0, well, the sine of 0 is 0. 1/2 times 0 is still 0. Okay, well, now the next number I'm plugging in is pi over 2. The sine of pi over 2 is 1. I multiply that by 1/2, and now I get 1/2. A maximum. Then, if I plug in pi, 1/2 sine pi, the sine of pi is 0 again. And then, if I plug in pi over 3, or sorry, 3 pi over 2, we're not going to plug in any of the weird ones like pi over 3 or pi over 6. 3 pi over 2, the sine of 3 pi over 2 is negative 1 times 1/2 is now negative 1/2. And then finally, the sine of 2 pi is 0 again. Okay. This pattern will happen for every sine function. You'll start with a 0 or the midline. Okay. We're going to actually change this. Let's call this the middle. Okay. Let's change these zeros to middle. Okay. So this is the middle of the function. And you can sort of see that from the picture right here. Let's get to the good picture. Right. This is the middle of the function. Okay. Now, the reason why I don't call it zeros is if we do vertical shifts, we can move this up and down. But for now, we're not moving it up and down. So this pattern that the sine function will start at the middle, then go max, then middle, then mid, then back to the middle, will always happen no matter what we are doing to this function. Notice that these happen to be the positive and negative amplitude. All right, so we can usually use that unless, of course, we shift the function up and down, and then there's going to be different formulas when we put this all together. Okay, but for now, we can use this pattern to help us graph this function. Let's graph this function. We got 0, 0. Next point was pi over 2, comma, 1/2. Let's call this 1 and 2. Let's not make this too skinny. So this would be 1/2. Then the next point is pi 0. That's right there. Then we have 3 pi over 2, negative 1/2. And then 2 pi 0. So I get my curve that is a little bit flatter. If I were to graph this curve, the parent function, that would still be 0. This would now be 1, 0, negative 1, 0. And you can see that we have vertically compress the function. Okay? Vertically compress the function by changing the amplitude. Let's do another one. Okay. So now my amplitude is 3 sine x, or sorry, my function is 3 sine x. So first, the period is 2 pi. Amplitude is that number right there. It doesn't matter if it's positive or negative. If it's negative, we're just going to do a reflection. Amplitude is 3. Okay, so now let's graph 3 sine x. Let's call this 1, 2, 3. So this is going to actually stretch the function a little bit because that number is bigger than 1. All right, so instead of doing all these separately, okay, if the period is 2 pi, a quarter period is, again, pi over 2. So my 5 key points are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, that's the x coordinate of my 5 key points. Again, how did I get that? I started at 0, and then you keep adding a quarter of the period to get the next one. Okay, my y coordinate is going to start at the middle, max, middle, min, back to the middle. Okay, so my graph would then become a little more stretched out. And we get a nice curve like that. Now, why don't we plug? So this is split up in third. Why don't we plug pi over 6, pi over 3, right? Pi over 4 is right there. Why don't we plug all these things in? Well, they're not easy to graph, right? Pi over 6 would be radical, or sorry, 1/2 times 3, so it would be 1.5. Oh, look, I got that. Oh, looks pretty good. Pi over 3 would be radical 3 over 2, 0.86 times 3. So it would really not be numbers that are easy to graph. So we're going to just stick with the 5 key points, and we're not going to make this crazy on ourselves. Okay? Let's try one with a negative in the front. Okay? So first, again, the amplitude is still going to be 2. The period is going to be 2 pi. A quarter of the period is still going to be pi over 2. Okay? So the x values for the 5 key points are going to be 0. I'm going to start at 0 unless we get to something more later. So I'm going to start at 0, and then I'm going to take pi over 2 and keep adding it to get my next point. So that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? Now, and I'm just going to do this right up here with these ones, find the y value of the 5 key points. So now, because there is a negative, it was -2, correct? -2 sine x, yeah. Because there's a negative in front, normally the sine function would go middle, max, middle, min, middle, okay? But if this was a max, the sine of pi, or sine of pi over 2, would be +1. When I multiply that -2, it's going to cause it to turn to a negative number. So basically, these two are just going to switch. The sine of 0 is still 0. The sine of pi is still 0. And the sine of 2 pi is still 0. Multiplied by -2 is just 0. The change happens with these two as this now becomes the -2 and this becomes the +2. The sine of 3 pi over 2 is -1. -1 times -2 gives me my +2. Okay, so those are the x coordinates and the y coordinates for the 5 key points. Okay, now I'm going to connect them, and this question actually said to graph it between -pi and 3 pi. So I'm going to have to keep this stretched from the original function. So we have 0, 0. Let's just call this 1, 2, 3. So this was negative 2, then 0, now a positive 2, and that is one cycle of the function. So one cycle of this function looks like that. So if I go from left to right, I started from here and then I went down. So I'm going to go down here and then back up. And this one is just going to travel. The pattern will just continue. So when we connect these, we just keep getting, and I'm totally missed on that one, we just keep getting a nice smooth curve to go left to right. Okay? And then of course you could keep this going as far as you wanted to, right? You could keep extending it. This goes forever to the left and the right. Try our checkpoint problem. Same problem as we had before, 1/2, but now it's a negative in the front. So again, let's take this. My amplitude is 1/2. Amplitude is always positive. By definition, the amplitude is the absolute value of whatever the A is. So amplitude is 1/2. The period, we'll get to that formula on the next page. For now, it's just 2 pi. Quarter period is 2 pi divided by 4, pi over 2. Again, that will change in a second. Okay. My 5 key points, we'll put them right over here. We start at my 0. Then we add a quarter period, add another quarter. Okay, there are my 5 key points. X values, Y values. Plug in 0, we get 0. Pi, we get 0. 2 pi, we get 0. Pi over 2 would normally give me a max, but now when I multiply it by the amplitude, it turns negative, and this one turns positive. So let's put the 1 there and the negative 1 there. So that way this graph isn't too skinny. And now you can see that we would go like this. Okay, so this would be one cycle of the function. To graph between negative pi and 3 pi, I would just continue the function to the left and to the right. And then, of course, I could just keep it going if I wanted to, right? You can keep this going as long as you have to, forever. Okay, so let's see what happens when we put a number there. Right? Putting a number there now would be a horizontal stretch or a horizontal compression. So if I were to take the parent function and I were to shrink it horizontally, that means maybe this point, let's clear this off. This point would move back to there, this point would move maybe to there, and this point would move, I don't know, let's just move it like that. What we have, something like that, you can see that we have now, if we shrink this horizontally, we have now changed the period. This whole cycle now finished in pi instead of 2 pi. So that's what we're going to be doing when we put this b in front of x, when we put this number in front of x. And it's going to be greater than 0. And what's going to happen is, normally, if we compare it to the original function, we know that a sine x completes one cycle from 0 to 2 pi. So then this new function completes one cycle as b times x increases from 0 to 2 pi. And we can see that if we divide out the b in this equation, that means that the new function, a sine bx, will start at 0 and finish one complete cycle in 2 pi divided by b. And that's very important. Formula's on the next page. Okay? So this function completes one cycle from 0 to 2 pi over b. The period is 2 pi over b. The graph of a sine bx is the graph of a sine of x horizontally shrunk by a factor of 1 over b, shrunk if b is bigger than 1, and stretched if b is a fraction. Because remember, the vertical stretch and compression and horizontal stretch and compression were opposites. So what do you have to remember? You must remember this formula, that the period of a sine function and cosine, tangent's a little different, but the period of a sine function is 2 pi divided by b. Amplitude's a, we talked about that last problem, but now the period, and then we're going to add a couple more to these, right? We're going to add phase shift, we're going to add vertical shift. So this is only 2 of the 4 transformations. The period is going to be 2 pi over b. Okay, let's see what this means. Okay, so now we're going to graph this function. Y is equal to 3 sine 2x. Amplitude is 3. The period, I can't just say it's 2 pi anymore. Okay, the formula for period is 2 pi divided by b. In the other problem, b was 1. So I could have done this if I wanted to, but I just, we glossed over it a little quickly because we haven't really talked about it yet. Okay, so now I'm really going to look at this and realize that the period is going to be 2 pi divided by 2, which is pi. I also still want to know the quarter period. So the quarter period is pi divided by 4. So we need this number. We need A. That's the amplitude. We need the period because I need it to get the quarter period. The quarter period is what I'm going to use to help me get the x values of my 5 key points. I'm still starting at 0 because we haven't done that yet. We haven't done a change in the phase shift yet. That's C. We'll get to that in a minute. But we now have changed the period. So the next key point happens a quarter period later, and then another quarter period, and then another quarter period, and finally 1 period. From 0 to pi is a distance of pi, so that is 1 period of the function. Okay, now let's get the y values. Let's rewrite this again. It is 3 sine 2x. Oops. Okay, so notice that the 3 is positive, so we're still going to go from 0, right? If I plug 0 in here, 0 times 2 is still 0. Sine of 0 is 0 times 3 is still 0. Watch what happens with pi over 2. The sine of pi over 2 would be 1, but we have to multiply the 2 first before we take the sine. So it's pi over 2 times 2, which is pi. Sine of pi is 0 again, so we still have this pattern of midpoint, midpoint, midpoint. Okay, and now this one is going to be the max, and this one is going to be the min, the amplitude. Okay, and now I have my 5 key points, the 5 points that I'm going to use to graph this function. And now that I have them, I'm going to connect them with a smooth curve. So we had 0, 0. Ooh, this graph doesn't have the next point. Well, let's call this 1, 2, 3. Okay, this graph doesn't have the next point. It only has pi over 2. Well, I know that's 0, and I know pi is 0. But pi over 4, well, is a quarter of the period, so that means it has to be halfway in between 0 and pi over 2, and it is. And 3 pi over 4 has to be halfway in between pi over 2, and pi. And those were my 5 key points, right? These two are always halfway in between all of these. All right, that's nice. Okay. So we can actually label these if we want. And that brings me to a good point, is that sometimes the graphs will have labels like this, where you have to sort of figure out where all the points go. Other times they'll be blank and you can just label it yourself, which is actually easier. So let's do 1 period of this function, and then we know that it'll just repeat itself to get my full function between 0 and 2 pi. Okay? Let's try it again. So notice what happened. This function got compressed. It completed 1 period from 0 to pi. The period got smaller. When we put a fraction next to x, the period is going to get longer. Okay, so let's try it. Amplitude is 2. Period is 2 pi divided by b. So the period is 2 pi divided by 1/2. 2 pi divided by 1/2 is the same as multiplying by 2, so the period is 4 pi, which makes the quarter period 4 pi divided by 4, which is just pi. So my 5 key points then, we start at the 0, we then go a quarter period each time. No fractions, nice and easy. Okay, then I start at the middle. This is a positive 2. Whoops. Positive 2, which means my next point is going to be the max, the middle, the min, and the middle again. Again, you can draw yourself a unit circle, a little circle to help you, right? I'm traveling this way, and I'm looking at I'm thinking about the y value, the y coordinate, because sine represents the y coordinate. Middle, max, middle, min, middle. Okay? And this is actually why we start with sine, because it's easier to visualize than cosine, which we're dealing with x coordinates. All right, so 0, 0, pi 2, 2 pi 0, 3 pi negative 2, 4 pi, and the question said graph it between 0 and 8 pi. So here's the first half, and then the second half just repeats itself as we graph the rest. So we actually graphed 2 periods of this function, 2 cycles of the function, and we can do more if we wanted to. Okay, so that was changing the period. Sometimes we now are going to have the next transformation. Okay? So let's see what happens. And this is going to be a little stranger. So let's see what happens when we now have a c in the mix here. Right? And then notice where this is right here. Remember our transformations. This is going to shift the function left or right. So normally our, right, and this is in parentheses, so it's all inside the sine function. So normally our parent function of y equals sine x goes between 0 and 2 pi for its period, when x is between 0 and 2 pi. Now the period is going to be everything in here. Okay, so I can't just divide out the b anymore. So we see now that when we add c to both sides, or all 3 sides here, we now start at c, and we still have this b, and we divide it out. We are now changing the starting point and the ending point of the function. Okay, this number, c over b, is called the phase shift. Okay, it's still a a horizontal shift, but remember I said that these functions like to call everything a little bit different. Instead of horizontal shift, we call it phase shift. Okay? Now, when we look at this, we should remember that a negative inside the function shifts the function right. A positive inside the function shifts the function left. All right, so you can use that that idea for the phase shift, okay? But I'm going to actually throw in something else here and say that if I want to use the phase shift and figure out the exact starting point of the function, okay? Instead of messing around with changing the sign of c, right? If you would have a plus there, c would actually be a negative. If we just take this whole value of c and say that we can make its phase shift as a negative c over b. Okay. So that's really what's happening here. Okay, but I don't want to deviate too much from the textbook, but you might see me do that from time to time, right? We are actually going to have to change the sign of c depending on what the inside of the parentheses look like. Okay, so the graph of this function, right, b is greater than 0, is obtained by horizontally shifting the graph of a sine bx, so this from the starting point to x is equal to c over b, my phase shift. Remember, if this is positive, it's to the right. If it's negative, it's to the left. Notice where the starting point of this function is. Now the starting point is not 0 anymore. The starting point is the phase shift. And this is always true. If you don't have a phase shift, right, then it starts at 0. The starting point of any function is its phase shift. These key points are still a quarter of the period later, but we're just shifting them to the right. Let's try this. Okay, now here's what I was talking about for phase shift, and you have to be very, very careful with this. Amplitude is 4. Period is 2 pi divided by b. So my period is 2 pi over 2, which is pi. Quarter period will be pi over 4. Phase shift. Okay. Now, the phase shift, the formula for the phase shift is c over b, but you have to decide whether c is positive or negative. Inside the parent function, notice there is a negative sign. So you do have to take, if you see a negative, right, you must make it a positive, right? The negative is supposed to be there, and that shifts the function right. So that means we want it to be a positive, c over b. Okay. If this was a positive, that would shift the function left. So that would mean it would be a negative, right? That the number right here would have to be negative. Okay, so you got to be very, very careful with that and realize what's happening with your phase shift and which way you're moving the function. Okay, so if my phase shift is c over b, that's this over this. So that's 2 pi over 3 divided by 2, which gives me 2 pi over 6. So the phase shift is pi over 3. Okay. That number is very important. This number and this number. Okay. And in order to get pi over 4, you needed the original period. Okay. So all these things are important to getting my 5 key points. And now we're going to do x and y almost together. Okay. The function, sine function, right, instead of just starting at 0, the sine function will always start at the phase shift. Okay? Every time we have a function, we're going to start it at the phase shift. Then we add a quarter of the period. So if we're starting here, and a quarter of the period, that's about 3, and a quarter of the period is pi over 4, we have to add pi over 4 and pi over 3 together. Remember, you need a common denominator, and when you add them together, you get 7 pi over 12. Then we add another quarter period. So we take 7 pi over 12 and we add pi over 4. Common denominator, reduce it when you're done, and we get 5 pi over 6. Then the next one, 13 pi over 12, and finally 4 pi over 3. The distance from here to here, from the start to the finish, should be 1 period. Pi over 3 to 4 pi over 3 is pi. Okay, 1 period. To get the y values, my pattern for now is still the same. Middle, what was my amplitude? 4. Max, middle, min, middle. And we have our 5 key points of my function. Again, weird fractions that we had to use a common denominator to help us calculate, but we got it. I'm gonna have to come back to those because this is not a perfect graph to deal with those things, right? And in fact, this is a terrible graph to deal with these things because none of the points are on the graph. So I have pi over 3, that's right there. And the next one was 7 pi over 12, which is a little bit bigger than pi over 2. Then 5 pi over 6, which should actually be on here. Yeah, here's 5 pi over 6. Then we have 13 pi over 12, which is a little bit bigger than, actually these are all pi over 6, so that's halfway in between. A little bit bigger than 1, so we get there. Actually, sorry, each of these are pi over 6, so this is pi over 3. And yeah, okay, this works because you can see that each one is going 1.5 blocks over, so that's not that bad. But it'd be better to make your points yourself on the graph be a little bit easier. Let's call this 1, 2, 3, and 4. And we see that we start at 0, then 4. So 0, 4, 0, -4, 0. And now I have my graph with a nice smooth curve. And I could extend this as far as I wanted to, either way you want. All right, let's try that again. And we'll show you how to do it on a plane graph, which again is much easier. Okay, so amplitude is 3. Period is 2 pi over b, which is 2 pi over 2, which is pi. Quarter period is pi over 4. Phase shift is going to be going to the right. So in the end, I need to have it positive. So it's going to be C, well, let's write the formula. So it's going to be C over B. So the phase shift is going to be pi over 3 over 2. So multiply by the reciprocal. So we get pi over 6. That is my starting point. So now, again, I have some fractions that are not particularly nice. That's okay. Got a calculator. So my first key point is the phase shift. The function starts at the phase shift. next key point is phase shift plus a quarter period, finding the common denominators, reducing when you're done, gives me 5 pi over 12. A quarter period later, plus pi over 4, again, gives me 2 pi over 3. Then 11 pi over 12, and finally 7 pi over 6. The amplitude is 3. There's no negative in the front. So middle, max, middle, min, middle. Okay? And watch why this is easier. Well, pi over 6 is positive. So I'm going to say pi over 6 is right there. I'm going to call this 5 pi over 12. I'm going to call this one same distance apart from each other, right? Because these are a quarter of the period. 2 pi over 3. And then 11 pi over 12. And then 7 pi over 6. Okay? So as long as you keep them the same distance apart from each other, right? It doesn't matter where on the blank graph that you put them, right? And then we just need a 3 and a negative 3. We can split this up if you really want to, right? And so I go 0, 3, 0, negative 3, 0, giving me my graph of one cycle, something like that. Okay. So much, much, much easier to draw in your own coordinates as opposed to having to fill out the graph on your own to figure out where the fractional things are. All right, so this was three shifts. Amplitude, period, phase shift, all with sine. We'll come back and do vertical shift at the end, but before we do that, we're now going to do cosine. Okay? This is going to go a little bit faster because now that we know how the sine function works, cosine is going to work the same way, except for the order of the coordinates. What that means is for sine function, we went middle, max, middle, min, middle. Cosine is not going to do that. Okay, so first, let's get the values of cosine. And remember, the cosine is now the x-coordinate of the graph. So this is the maximum the x-coordinate is going to be. This is the middle. That is the minimum. That is the middle. And then back to the maximum. And we can tell that with my outputs. So the cosine of 0, and I'm not going to put the pi over 4s in here. We can just pop through these real quick. The cosine of 0 is 1. This is radical 3 over 2. This is 1/2. And then that is 0. Then we go 1/2. Oh, sorry. We go negative 1/2. Right? Think of the circle. Right? That's pi over 2. Now x is going to be negative as we go this way. Negative 1/2. Negative radical 3 over 2. Negative 1. Right? That's a negative 1 on the unit circle. And now we're going to start to go more positive as we go back this way. So that's negative radical 3 over 2. Negative 1/2. 0. 1/2. Radical 3 over 2. And 1. Again, those are my 5 key points, the most interesting points. Intercepts, mins, and maxes. And you can see that that's the max, that's the middle, this is the min, that's the middle, and that's the max. So a different order than the sine function. And again, I like to use the unit circle to help me. Right? I know I'm going to start here. Even though it says y equals cosine x, x is the angle, the cosine function spits out the x coordinate of that angle, and the y is just your output as you graph it. which if we flip all the way back to my visualization, you can see that the blue one on top, the cosine function, is mapping the x coordinate, right? So now it's at its max, now it's at its min, and it's sort of shifting this x coordinate left and right to a graph that goes in terms of y. So that's why we start with sine, because it's a little less confusing. Okay? So if you can remember the pattern, that would help a lot with remembering this sort of order, that the cosine function starts at the max, then it goes to the middle, then the mid, then the middle, then back to the max. Okay, and here's a picture. Okay, here's my nice picture plotting the points. We can see that there's the max, my middle, my min, my middle, and back to the max. Looks kind of like the sine. In fact, if you were to start here, it is the sine function, just shifted to the left. Okay, so cosine functions and sine functions are almost the same thing, because all those coordinates on this unit circle, right, all these coordinates were all the same at these angles, right? The sine at pi over 6 was 1/2. The cosine, or the sine at radical 3, or pi over 3, was radical 3 over 2. So these values are very, very similar, so my graphs are going to be very similar as well. In fact, the steps we're going to do them are going to be exactly the same. We are going to start at the phase shift, we're going to add quarter periods, and then we're going to plot the points at those quarter periods. Okay. Some properties is that the domain is from negative infinity to positive infinity, and the graph extends infinitely to the left and right. Range is from -1 to +1, just like the sine. The period is 2 pi, unless we change it, just like the sine. The only difference is this function is even. It has a reflection the same across the y-axis, as opposed to the sine function, which was odd. Okay, and we just talked about this, is that can we see that the graph of the cosine and the graph of the sine is the same if you put in a phase shift of -pi over 2. Okay. Because of this, the graphs of a sine and cosine function are both called sinusoidal graphs. Okay, so a cosine function is a sinusoidal graph. All right, so let's graph some variations. Okay, we're going to do the same thing, right? We're going to find amplitudes, periods, phase shifts, and graph them all. Formulas are the same. The amplitude is the absolute value of A. The period is still 2 pi over V. The difference is where it starts, the y value of where it starts. Okay, that's weird. Let's see what happens. Amplitude is +3. There's a negative in the front. That's fine, it's just a reflection. Okay, so we're just going to reverse my order of mins and maxes. Okay, weird. The period is always 2 pi divided by whatever b happens to be. So my period is going to be 2 pi divided by pi over 2. Okay, 2 pi times 2 over pi. Right, the pi's cancel out, and we get my period is 4 with no pi's in it. Not going to happen very often because there's a b in with pi, or there's a pi in for b. Okay, I can handle that. Quarter period is 4 divided by 4. So my quarter period is 1. This is going to be nice and easy. Find the values, x values for the 5 key points. Starts with the phase shift. There is no phase shift. Add a quarter of the period. That was nice. No fractions to deal with. All right, so normally the cosine function starts at a max, then a 0, then a min, then a 0, right? X values, how far left and right, and then a max. So this one's going to be 0. This one's going to be 0. But because A is -3, instead of starting at +3, we're going to switch it. We're going to reflect it. And now, those points are pretty easy to graph. 0, -3. Okay? 0, -3. These go by 2s, so right, that's 1, that's -1, that's -3, that's 1, that's 3. So 0, -3. That's 1, 2, 3, 4. Okay? Then we have 1, 0, 2, 3, 3, 0, 4, -3. And then, again, when I graph this, it's still going to be a nice smooth curve that I can just keep going as far as I want. Okay? Try our checkpoint problem. Okay, so again, pi in for b gives me weirder numbers. So a is 4, period is 2 pi over b, which gives me 2 pi over pi, which is 2. Quarter period is 1/2. Key points: start at 0, start at the phase shift, there is no phase shift, add a quarter period, and not 3 pi, 3 over 2, and 1, and 2, and then the cosine function goes from, starts at the maximum, reversed, reflected, then my middle, then would be my minimum, but now it's my maximum, my middle, and back to the maximum. To graph, 0, -4, 1/2. Ooh, I have still 1, 2, 3, 4. Okay, so 1/2 is right there. 1/2, 0, 1, 4, 3 over 2, 0, and -2, -4. And the question said to graph it between -2 and +2, so I would just keep that going this way. And we would get my graph that looks like a nice smooth curve. Graph. All right, let's throw in a phase shift. Okay, so same thing, right? We have to decide whether or not the phase shift is going to move the function to the left or to the right. It's going to be the same thing. A negative moves the function to the right, a positive moves the function to the left, and the formula for phase shift is C over B. Okay? Again, if you see a negative, right, that means that C is positive, and if we see a positive, it means we have to change it to move it to the left. Okay, so normal number in there, that makes this a little bit easier. Amplitude is 1/2. Period is 2 pi divided by b. So that gives me 2 pi divided by 4 pi over 2. Quarter period is pi over 2 divided by 4 divided by 1, pi over 2 divided by 4 gives me pi over 8. Not perfect, but you know, we'll make it. We'll deal with that. All right, next, phase shift is a positive number. That means that C is actually going to be negative, right? We always have to change the sign here, right? There's the parent function. This is a positive. That means it's really 4x minus a negative pi. Okay, so that means that the phase shift is negative pi over 4. Okay. Well, at least the common denominators are nice. All right, so let's throw both of these steps together. X and Y values. The function starts at the phase shift. Then we add a quarter of the period to get the next key point. That would be negative pi over 8, then 0, then pi over 8, and then finally pi over 4. Cosine function. I forget the amplitude. I think it was 1/2. Okay, a positive 1/2. So that means cosine function starts at the max, the middle, the min, the middle, and back to the maximum. Okay. There are my 5 key points. Now we just go ahead and graph them. Smooth curve. The function starts at, well, this is pi over 4, so negative pi over 4, 1/2. So let's just call this 1. Let's keep this nice and flat. So negative pi over 4, it starts at 1/2, 0, negative 1/2, 0, 1/2. And we get a nice little flat curve that we can, of course, keep going as far as you want to. Both left and, both right and to the left. And we get a little flat, squiggly curve. Okay? Let's try one more of those with our checks point here. So we find our, and we got a nice plane graph to do right here. So my amplitude is 3 over 2. My period is 2 pi over b, which is 2 pi over 2. So that's pi, making my quarter period pi over 4. Phase shift is going to be c, negative pi, right? It's negative because I want this function to go left, over 2, negative pi over 2. Okay, key points. Start at the phase shift, negative pi over 2. Next, take that phase shift and add a quarter of the period. And we get negative pi over 4, then 0, pi over 4, and then pi over 2. Y values, that's the maximum, then 0, minimum, then 0, then back to the max. Okay, so there's actually 2 numbers on both of these sides. I'm just going to keep this nice and small and not repeat it. So we get negative pi over 2 there, negative pi over 4, 0, and pi over 2. And let's call that 1 and 2. So my 3.5 is going to be right there. 1, 2, 1, 2, 3, 4, 5 key points to give me a little curve. All right. So we've done a lot. Okay. There's one more. Right? So the last thing we have to do is talk about D. All right, so D is a vertical shift. So what's going to happen now is if D is positive, it's going to move the whole function up, which moves the midline. And it moves the whole function down. So it moves the middle, it moves the min, and it moves the max. So when we're dealing with D is when we're listing out our key points here, we're not going to be able to just look at the amplitude and find the min and the max and just use 0 for the middle. We're actually going to have to use D to find the max and the mins. So when we do that, before we get that, here are my 2 formulas. So the midline is going to be D. The max is going to be d plus absolute value of a. And the minimum is going to be d minus the amplitude. Makes sense, right? How high up, how high go? If the middle is d, the max you're going to add the amplitude, the mid you're going to take it away. Absolute value, because if it's a negative in the front, it's just going to reflect the function, and the max and the min are just going to be in different places. They're still going to be the same numbers. Okay, so when you're graphing any function, right, without any of the steps listed below, here's what I want you to do. I want you to start with the amplitude. That's 1/2. Then the period is 2 pi over b. Well, b is 1, so that's great. The period is just 2 pi. Then the quarter period, which is pi over 2, 2 pi over 4. Okay. Then the phase shift. Okay, phase shift, if this was in parentheses, that would be a phase shift, but it's not. So the phase shift here is 0. That's nice. Now we come to the last one, which is the vertical shift. The vertical shift is -1, which makes the middle -1, the min -1, or let's do max first. Max -1 plus 1/2, and the min -1 minus 1/2. Okay, so all these different pieces go into helping you find your 5 key points. Okay, my 5 key points are key points. Start at the phase shift. Then we go and add a quarter period. Then this is a cosine function. So remember the pattern of a cosine function. It starts at the max, then it goes to the middle, then it goes to the minimum, then back to the middle, and finally to the maximum. And now we have our 5 key points. Now we can put them on my graph. So this would be, let's just call this 1 and 2. Yeah, that works. -1, -2. All right, so notice something when I graph this. 0, -1/2. So we got 0, -1/2. There's my first point. Then the next point is pi over 2, -1. Then my next point would be pi -3 over 2. And this one, and then this one. Notice that the middle of this function is no longer the x-axis. This is the middle. And that's okay because I shifted the function down. I moved this function down 1, right? The vertical shift was 1. Okay? So that is sort of all the different transformations that we could do with a cosine function. This one's kind of the same. Let's skip over this one and finish this up. Here's a nice page with all of the different transformations. Again, this, I don't want to get confusing with phase shift. You can just use C over B and just remember to put a positive or negative depending on which way the function's going, right? If the function's going right, the phase shift has to be positive. If the function's going left, the phase shift has to be negative. If you wanted to, and look, the reason why they put a negative there is they use, in this textbook, different textbook, they use a positive inside of the sinusoidal function. Our textbook uses a negative inside of the sinusoidal function definition. It doesn't really matter. I personally like the negative one because that's what we're used to. And just remember that the phase shift just remember that you need to decide, you need to put a positive or negative depending on what direction you're going. We didn't really talk about that. Frequency is just the reciprocal of period. So amplitude, absolute value of A, period is 2 pi over the absolute value of B. Frequency is the reciprocal of period. Phase shift, we'll just use, C over B. Vertical shift is D, and the midline is the Y is equal to the D. All right, so let's finish up this chapter with some word problems. And you could talk a little bit about breathing there. Some graphing utilities have a sine regression, which means that it will spit out your sine function form, but we can do it by hand. So here's a graph. This shows, here's our graph down here, right? Okay, looks good. This shows one complete breathing cycle. The cycle consists of inhaling and exhaling. It takes place every 5 seconds. It's positive when we exhale, negative when we inhale. Positive when we inhale, negative when we exhale. It's measured in liters. It represents velocity, blah, 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 blah. We're going to make a formula that does this from this picture. Well, I know the important points. I know that A, the amplitude, there's no shift left or right. Amplitude is the distance from the middle to the top. Amplitude is going to be 0.6. So my formula is going to be y is equal to 0.6 sine, I need B. Well, remember that period is equal to 2 pi over B. The period here is 5 seconds. So 2 pi over B. So multiply both sides by B. So 5B is equal to 2 pi. Divide out the 5, and B is equal to 2 pi over 5. So here is my formula, and it is pretty simple to get a sine graph from the function. Now I could get a cosine from this as well, but I would need to phase shift it, right? Because now it's phase shifted to the right. And I don't want to have to do that. So stick with the one, right? The reason why I pick sine is because it starts at 0. If it started at the maximum, I would pick cosine. Okay. Let's model this tidal cycle. It shows that the depth of water of the boat is, at the boat dock varies with the tides, right? The depth is 5 feet at low tide, 13 feet at high tide. On a certain day, the low tide occurs at 4 a.m. and the high tide at 10 a.m. If y represents the depth of the water in feet, use a sine function to model the water's depth. Okay, so first thing is we need A, B, C, and D. D is probably the easiest because it's the middle. Okay. A, amplitude. It's the distance from the middle to the top and the middle to the bottom. So it is 4. Okay, it's not 13. Okay, because we did a shift. We did a vertical shift. Okay. Now we just need B and C. So the period is equal to 2 pi over B. Well, what did I say? What did we say here? Is that well, let's look at a bottom to another bottom. 4, 2, 16. So the period is 12. Okay, so that would be 2 pi over 12. So B is pi over 6. Okay. Now we need a C, phase shift. The phase shift is C over B. Okay, now here's the trick, is I can take this number as the phase shift, this number as the phase shift. I can take any point I want, but you should take the first one, right? Because this is a sine function, it keeps repeating. So this seems like it is halfway in between 4 and 10. So that would be 7. So my phase shift is 7, and that's equal to some number over b, which is pi over 6. So multiply both sides by pi over 6, and we get that 7 pi over 6 is equal to c. And now we can write my function, that y is equal to amplitude sine of pi over 6, don't forget the x, minus, because I shifted this function right, 7 pi over 6 plus 9. A, B, C, and D. Okay. This has gone on long enough, so I'll save some of these extra problems on how to go about making a graph for another video at a later time. That was 4-5, graphing the sine and cosine function.